Hey guys, welcome back to my channel. Today we're going to be talking about some more chemistry concepts. In specific, we're going to talk about enthalpy, entropy, and Gibbs Free Energy. So as you can see, I've written down quite basic definition of enthalpy is energy change over the course of a reaction, or the change in H. So H would be energy, change in energy. So something that would go underneath enthalpy is Hess's law, which we'll learn about in future videos. But the unit for enthalpy is kilojoules over mole. That's the unit for enthalpy. So there's two different sort of processes under enthalpy. There's endothermic and exothermic reactions. So endothermic, you might have heard this in biology, but endothermic and exothermic. So endothermic is is when energy is taken in, and exothermic is when energy is released. So something to know is that the change in H in a reaction. So change in H of a reaction equals change in H of the product minus the change in H of the reactant. Now this is, let me make this more clear. So this is because, like, let's say you have 2 plus 3 equals 5, but you don't know what 2 is. So what you do is you don't know what 2 is. So what you would do is, say you don't know that, that's x, a variable. So what you do is you do 5, the product, minus the reactants, one of the reactants, gives you the other one. And it's kind of the same concept with reactions in enthalpy. So for exothermic and endothermic, there are some certain graphs that you will need to know, and we'll talk about that in another video. But just know that endothermic is the absorption of energy, and exothermic is the release of energy. So now let's talk about entropy. So the thing about entropy is to be quite simple. So enthalpy was change in H, so entropy is the change in S. And S is randomness. So what S is, it is randomness or disorder. So entropy, quite simply, is just the change in randomness or disorder. So the unit for entropy is joules over mole times K, or mole times Kelvin. So what's important to know about entropy is that when you have, when your change in S is positive, that means there is more disorder. And when your change in S is negative, I can probably tell that there's more order rather than disorder. So what's that kind of synonymous with more disorder or more order is the states of matter. So when you shift from different states of matter, solid, liquid, to a gas, if you shift from here to here, or here to here, or here to here even if that happens, as you move from different states of matter, your change in S, or your change in randomness, increases. That's a very important key concept. And another thing, as we said in the past one, as when we were talking about enthalpy, is the change in S of the reaction equals the change in S of the product minus a change in S of the reactant. It's the same thing as we said before with the change in H. Now let's talk about Gibbs Free Energy. Okay, Gibbs Free Energy. So what Gibbs Free Energy is to put quite simply, is the change in G. So it's the change in spontaneity. I think it's like spontaneity. Change in spontaneity, something like that. So the unit for this is kilojoules over mole, same as enthalpy. So there's a formula for this actually. So it's change in G is equal to the change in H with enthalpy minus the temperature of the change in S. And as we do with all the other ones, if the change in G is positive, that means that it is non-spontaneous, and if the change in G is negative, that means it is spontaneous. So there's a chart that I want to go through in a few videos after this, but basically it shows you the different combinations of this formula and what different outcomes you can get. But really, if you follow this formula and you have, and you should get all of those in a problem, but we can go over some in the next few videos. Okay, so as always, I will see you guys in the next video. We'll do some more. We'll talk more about enthalpy, entropy, and Gibbs Free Energy, do the charts and the graphs, and yeah, and as always, thank you guys so much, and make sure to like and subscribe.